This lesson, we're going to be working on solving complex linear equations. And what that really means here is more than two steps. We might be working with having multiple variables on the same side or even variables on opposite sides of the equation. For this video, I'm going to work on solving the problem using algebra tiles and then solving the problem using the standard process. And evaluating algebraic expressions and solving linear equations sounds like fun, said everyone. Because I just said it, so this is no longer true. So this is going to be awesome. I'm really excited. So when we set up the first problem, we look here at the top, we have 3x plus 2x plus 5 equals 12. So we have more than one set of x's on the left side of the equation. Now, the nice thing about equations is the step between this and the actual problem that we've been working with before is really only one extra step. So what I'm going to do right here is I've set up algebra tiles. So I have 3x plus 2x plus 5 chips is equal to 12 positive chips here on the right. So let me make sure I counted right. I did. I have 12. So what I see right away is I notice that these x's can just combine to be 5 total x's. And then I have 5 chips here. And I'm going to organize 5 chips right here. And it looks like I can actually get rid of all of these chips right away, which leaves me with, and I'm going to write it up here, 5x equals 7. And then I'm just going to simply divide both sides by 5, which is going to give me each individual x is equal to 1 or 7/5 or 1 2/5 or 1 4/10. So any of those answers would be fine. I don't have a problem with each one. But if you notice that what I did here when I have 3x and 2x, just right away, I just combined them together to see what I ended up just getting all of the x's combined. So let's solve it using the standard process. So I'm going to draw my line here. Awesome. And then let's do what we just did in that process. So the first thing is I'm going to combine these x's together to give me 5 x's. Then I'm going to treat the rest of the problem like normal and right there. Now I'm going to subtract 5 from both sides. That's what I did. I took 5 chips away from the left and right. That's 0. So I get 5x equals 7. Then I divide both sides by 5. And I get x equals, and I'm going to write it as 1 2/5. Because I had those 3 different ways to write it, I'm going to leave it like that. Now to check my answer, I'm going to put it as the decimal 1 4/10 to check, because I think you guys will like that one a little bit better. And then let's just go back and check. So I'm going to do 3 times 1 4/10 plus 2 times 1 4/10 plus 5. And all of this has to be equal to 12. Well, 3 times 1 4/10, that's going to be equal to 4 2/10, because 3 times 14 is 42. 2 times 14 is 28, so this is going to be 2 8/10, and then we're going to add 5. These together are going to be 7, and 7 plus 5 is equal to 12, so that means our answer has to be correct. So there's the first example of when you have multiple variables on the same side. You want to combine those variables together, and then you just solve the problem like normal. This video is pretty short. This is actually our last problem. But we're going to have to solve it as algebra tiles first. So what we have is 3x plus 4 equals 2x minus 1. It's kind of a complicated problem to set up on algebra tiles, so I went ahead and did it right away. On the left side, we have 3 x's plus 4 1's. And on the right side, we have 2x's and a -1. Now, the first thing that I want to do is I want to move all of the plus minus chips to one side or the other. I like to move the plus minus chips to the right and then the x's left. And it's correct to do either way, but that's just the way that I like. So to get rid of these 4 chips, I am going to add 4 negative chips to both sides of the board. Okay? So now the nice thing here is these are all equal to 0. So I can actually delete all of them. And then I just have 5 negative chips on the right. And I have now 3x equals 2x minus 5. But I need to make sure I get my x's all over to the left side. So what I'm actually going to do is I'm going to do that same process with those chips, except this time I'm going to do it with my x's. So I'm going to add 2 negative x's. Whoops, let's get rid of that bad boy. I'm going to add 2 negative x's to both sides of the equation. Same process that I did with the other one, or with the plus minus chips. Same process. Now, these, a negative 2x and a positive 2x, add to be 0. So they are all gone. Now over here, these two are also going to add to 0. And I'm actually left with my answer of 1 positive x equals -5. Now that we've done it with plus minus chips, I'm actually going to solve this the standard way. And there's actually a couple different ways to do it. So I'm going to solve the same problem a few different ways. The first way is I'm going to do the same process that I just did with the plus minus chips. I'm going to subtract 4 from both sides right away. This is equal to 0. So I get 3x equals 2x minus 5. Now I need to move the x's left by subtracting 2x from both sides. So I have these are equal to 0. 3x's minus 2x's is equal to 1x. And I get 1x equals -5. And that is actually the correct answer, because if we check it, we're going to do 3 times -5 plus 4. And on the right side, we're going to do 2 times -5 minus 1. And we're hoping these are equal. 3 times -5, that's -15, plus 4 is equal to, this is -10 minus 1 more. So we end up getting -11 equals -11, which is true. So we actually have the right answer. Now let's go all the way back. And let's think about when we had this original problem. We had an option of a starting point, and I said that you can do it multiple ways. And let's see what that actually looks like if we choose to go the opposite direction. There we go. Now last time I moved the numbers to the right by subtracting 4 from both sides. What if I choose to move the numbers left? Well, to get rid of this number, I'm going to add 1 to both sides of the equation. Well, this is equal to 0. 3x, but now it's plus 5, is equal to 2x. Now, the mistake that people make is they end up subtracting 2x from both sides, which actually creates a 0 on the right side of the equation, which is the problem. We need to have, if we moved the numbers left, we have to move the x's right. And I'm going to subtract 3x from both sides to do exactly that. So I get positive 5 is equal to 2x minus 3x is -1x. Well, now I have one extra step. I have to divide both sides by -1 because I need my x to be positive 1x. And positive 1x ends up being equal to -5. So I ended up getting the same number both ways. It turned out that this was an extra step from what I did before, but I did get the same answer both ways. And that's the best part of linear equations. There are tons of ways to solve these problems, but if you're right, your check will always work.